Thank you very much, and I'm happy to have been invited to share some of the work we're doing. So I'm a basic scientist, so this is going to be more about sort of what basically is happening with what we believe is currently normal aging. So I'm part of the Linus Institute's Healthy Aging program, and basically our goal is to enhance health span. So we've made medicine has made progress in increasing our average lifespan, but that the health span is lagging. So really it means kind of that we're living longer with less vitality. And so our goal is to try and move this trajectory over so that you're living longer with high vitality, less time that you've got frailty and disability in your life. And so that's what we're aiming for. So first you have to know what you're dealing with and what you're trying to make an impact on. So as far as brain aging goes, the effects on health span, so as the brain ages, it does impact our activities of daily living. If you don't remember well, you don't remember that you left the stove on, things like that. Ultimately, that can lead to a lack of ability to live independently. If you're not flexible, if your brain is not flexible, then you're going to have more difficulty dealing with other disabilities in your body. Even though muscle and skeletal problems contribute to gait, slower gait and gait instability, the brain also is unable to adapt to those muscle and bone changes as well, and there's some balance issues that are coordinated centrally that are affected. And then with the decrease in our senses, with vision and hearing problems and things like that, your brain is less able to adapt to that and make compensations for it as we get older. So this is just kind of an overview of what I'm going to talk about today. So we're going to talk about cognitive aging, which is cognition is your higher brain functions, and we'll talk about that. And then aging of some of other brain functions, what's going on biologically, and then what are the current recommendations for healthy brain aging. So cognition. So basically this is your ability to acquire new knowledge and to understand it based on your thinking, your experiences, what your senses are telling you. So in the little thought bubble there, knowing, understanding, being able to apply the knowledge, being able to analyze it, synthesize and evaluate, all these are your higher brain functions involved in cognition. And some of the examples are memory is a cognitive function, language, speed of processing, and then executive function, which is cognitive flexibility, attention, and working memory. And I'll talk a little bit about some of the definitions of these things. So first off, there's some good news. It's not all bad. Our world and verbal knowledge increases with age. And so basically, if you use big words and talk about foreign places, you've still got the younger people beat. So keep that in mind. Short-term memory. Now, I used to say short-term memory when I was talking to students was remembering a phone number long enough to dial it. None of them know what that means. But so I've got to come up with a new example for the younger generation. But at any rate, our short-term memory, the ability to remember something for less than 30 seconds, that's well preserved with aging. Language is mostly preserved. You don't start to see declines until your 70s. And that's things like verbal fluency. They test that by saying, name everything you can think of that starts with the letter A. Or name as many animals as you can. That's verbal fluency. And that's well preserved up until our 70s. And naming objects, being shown pictures and being able to name them is preserved up until the 70s. So that's the good news. Some of the things that do show more changes as we get older, executive function, and again, this had kind of some subsets to it, and we'll talk about those. Cognitive flexibility is one of them. So again, it's like an example of today, having to figure out a different place to park. You had to adapt to the situation, and your ability to do that is taken care of by your frontal cortex. In addition, I usually use this example of as far as cognitive flexibility. If you take the same route to work every day, and one day you come across road construction and a sign that says that the road construction is going to last for several weeks. Okay, so cognitive flexibility is you ignoring your GPS and figuring out how to come up with an alternative route. So you got to do that immediately and be open to doing that. But then you also, since it said that it was going to last for a while, you have to remember that that's a problem and not go your usual route, or you're going to be late again. Okay, so remembering that there's been a change in rules and being able to adapt to that over time is a good thing. Like I said, I ran into that today when in Philomath, if you can imagine, I ran into traffic. There was a train pulling into the lumber yard, and he stopped right in the middle of the road, and was absolutely no indication that he was going to move at any time. So I thought, okay, I'm running late. I'm going to be adaptable. So I turn around and head to 13th Street, which has construction on it. Got to 19th Street, went around, back around Grange, got back to the highway, and of course, the train had moved by then. Traffic was flowing just fine. But anyway, so I'll know in the future to give a little bit more time heading that direction. But at any rate, so perseveration is where you stick to that old route. You can't remember that you need to take a new route, and that increases with age. Interference, inhibition declines. Being able to inhibit your old route and take that new route, that declines with age, after age 60. Another executive function is attention, and that declines by your 60s. Divided attention, I love this picture. So this is in a railway station. It's a statue, and this couple is hugging while looking at their phones. So that's an example of modern day divided attention. And that type of thing declines with age. Selective attention, being able to be in a kind of noisy situation and paying attention to the person that you're talking to, not being distracted by all the other noise, that also shows declines with age. Working memory. So working memory is something where it's something that you use for a relatively short period of time. But you have to remember the information, you have to update it as things change, and you need to, pay attention to it. And the best example I can give of this is playing bridge. So you're within one hand of playing bridge. You have to remember what the bid is. You have to remember what the danger cards are that are out there. But with every play, those danger cards, that changes, right? So you've got to update that. And such. But then when the hand is over, you need to forget all that, because it means absolutely nothing to the next hand. Okay, so working memory, that is somewhat preserved, but as the difficulty increases, then we see declines with age. Long-term memory, so this is affected the earliest of our cognitive functions, and it's new learning that's affected more than old. You are going to be able to remember things that you learned a long time ago better than you are going to be able to learn something new. Procedural memory. So basically, so we're showing the guy here playing the violin. So things that are more like motor tasks and things like that, that's really well preserved with age. But episodic memory, being able to remember an event or remember facts, and I should say learn these new facts and these new events, that already starts declining from 30 years of age. We see declines as we get older. Speed of processing, this is another thing that's affected earlier. We're not as fast as we used to be. And it's not just motor, it's being able to think and make a decision and things like that. All of that declines with age. So some other brain functions, I think I mentioned this before. So motor function, again, this is complicated because you've got declines in muscle mass, and you may have bone changes and things like that that are contributing to your ability to move. But the motor cortices in your brain also show declines with age, and so not as able to compensate for some of these skeletal muscular changes and things like that. Gait is also complicated. It's both influenced by the brain as well as your muscles and your bones. And so you've got the stoop posture, diminished arm swings, shorter stride, and difficulty with balance. And all of that is a combination of changes in the structure of your body as well as in the brain. And then sensory function, decrease in vibratory sense, abnormalities with joint sense. These are things that we use to help maintain our balance and to give your brain information about where your body is and where it is in space and such. And so that declines with age, and that contributes to the balance problems. And then, of course, vision declines and hearing declines. Okay, so a little bit about the biology. So what's going wrong? So the brain weight and the size decreases with age. So easiest to see perhaps in this picture, we've got a normal brain here, the surface of a normal brain, and you see an older brain, you've got a lot more space and shrinkage of the brain. This again is a scan of a young brain. You can see that it's pretty much filling the skull. But in this one, the dark areas that you're seeing, that's increased space. So you've got shrinkage out here, you've got increased ventricle sizes and things like that. So we've got shrinkage going on with age. It isn't universal in our brains, so certain brain regions are relatively spared. So interestingly enough, our visual cortex doesn't change very much, so a lot of our vision problems are really more peripheral than they are central. But the prefrontal cortex, which is where executive function and speed of processing is conducted, that shows declines with age. And then the hippocampus, which is important for making new memories, that shows declines with age. Okay, some good news again. So you probably have heard over your lifetime that we start losing neurons in our 30s or 40s, and they're just gone. But the fact is that that was based on the way that it was being studied. People were looking at densities and calling it a decrease in numbers. And actually, in rodents, we're seeing no decline in neuronal numbers with age. So neurons, I forgot to mention. So this is the main cell in your brain that is communicating, providing the communication, neuron to neuron. And then in humans as well, there's a slight decline, but it's nowhere near what people had thought. So the bad news is that the neurons do shrink in size. And so one of the problems with that is neurons are communicating with each other. They need to contact, or at least come in close contact with each other. And if you're a smaller size, then that means you have less surface area to receive information from other neurons. So it limits our communication. Okay, another thing that you probably heard is that you're born with as many neurons as you're ever going to have. And that's not true anymore. So we know now that we have new neurons being born throughout life. They're kind of restricted in their area, but basically what you see in green up there is all neurons that have been born after the onset of adulthood. Okay. So the bad news is that with age, and this is a rodent study, with age we have less neurons being born than when we're younger, and we have less of them surviving than we're younger. So that's something that people are actively looking into. How can we increase that birth rate of those new neurons, and how can we increase the survival rate? But the fact that we have that possibility and that plasticity is very hopeful, something that we can key into. All right. So current recommendations, and I take these from the National Institute on Aging, from the National Institutes of Health. So I really recommend that you look at their website, and they will summarize all the research that is being done by the National Institute on Aging and provide helpful practical information to you. I find it interesting that currently there are no drugs or pills that are being recommended or touted by NIH. It's more about lifestyle at this point. That's what the majority of the evidence is for. Now, there are some drugs that are being looked into that could help increase lifespan and healthy lifespan, but it's too early right now to talk about them. So I'm going to talk about these things. So body exercise, brain exercise, social interactions, and healthy diet, all things that were mentioned in the last talk. So what does exercise do for you? Well, in rodent studies, we know that animals that exercise have more new neurons born, and the neurons survive better. So that's one intervention that you can take advantage of. They have increased memory, animals that are exercising. So this is a task that's done real commonly in rodents called the Morris water maze. It's got a hidden platform beneath the surface, and they're using landmarks around the room like we would use buildings or mountains or whatever as landmarks. And so it's a test of spatial memory. So even though you can see where the platform is, the animal can't. And so you can see that the animal up there that was a non-runner is taking a lot more time to learn that position than the one that was exercising. So this is after several trials. In humans, we see that, that we get increased volume of the hippocampus with exercise. So again, that was an area that showed decline with age, and exercise helps reverse that. So brain exercise and social interactions. So this is being studied in rodents with an intervention called Enriched Environment. So a normal rodent lives its life in a cage with bedding and food and water, but it's pretty boring. And so with Enriched Environment, they put them in a larger cage. They give them toys, things to interact with. Oftentimes, in normal studies, the rodent is alone in its cage, so they've put them together with other rodents so that there's a chance for social interaction and such. And you can see that this gives them the opportunity to stimulate different parts of their brain, the visual system, the motor system, because they're running or interacting with things, cognitive, and things like that. So I always say that that for us, this means that we have to go to Disney World every day, but they have to change the rides every 2 weeks so that we don't get bored. So what does Enriched Environment do? So I told you before that with aging, our neurons are shrinking. Enriched Environment shows an increase in size of the neurons and an increase in complexity. You can see all those little spikes and stuff, much more on that one than on this one. It's like all of that increases the surface area of that neuron, which means it can receive communication from more neurons. So all of that is good for increasing communication in your brain. Enriched Environment increases the number of new neurons. So it increases it in young animals as well as old. So Enriched Environment is good for what ails our aging brains. So as far as what you can do with brain exercise, short of getting multiple e-tickets from Disney World. That shows my age too. So change your habits. So interestingly enough, if you always take the same route to go to the grocery store, if you always get ready in the morning the same way and such, you're really kind of on remote control, and you're not using your higher brain functions. And so take a different route. It's going to force you to pay more attention. It's going to force you to see new things, take in new things, and you're going to be more engaged in your higher cognitive functions if you do that. If you brush your teeth with your right hand, try it with your left. If nothing else, it'll be funny, and bring a little life to your day. That's right. So develop new interests or hobbies. Again, this is something that will engage you, something that you'll want to pay attention to, and will challenge you. Learn something new, like language or playing an instrument, something like that. So it's kind of the use it or lose it type thing, that you really can kind of beef up your brain by using it in different ways. So cognitive training. So there are a lot of games out there on the web. Nintendo has games and things like that. And this has been studied really intensely as to whether this is useful or not. And the sort of overwhelming outcome has been that whatever that game, whatever function that game trains you for, you will see improvements in. But what it doesn't do is it doesn't generalize to the rest of your brain functions. So it's kind of like if you were to do curls with just one arm, it's not necessarily going to beef up the muscles in the other arm. And it seems like the same thing here. So for instance, reasoning training helps with reasoning, but it doesn't improve memory. And likewise, memory training improves memory, but it didn't improve reasoning. Okay? But so you just do a number of them, sort of do different things so that you can beef up different areas. And you can see, though, that the outcome, these different specific brain functions, can have multiple effects sort of on your daily living and such. So I think that the bottom line is that it didn't, I think they were hoping that you could train in one thing and it would help your whole brain. That has not proven true, but just do multiple, do an attention game, do a memory game, do things like that, and ultimately you'll be able to help. Okay, so as far as diet goes, so NIA has not sort of committed to a recommendation on diet, but we do have, the USDA does have the My Plate for older adults that's been developed by Tufts University. So again, you can go and see that. And NIA does mention the Mediterranean diet as something that has some evidence to support help with brain aging, but still needs to be studied more. Okay, so as part of the Linus Pauling Institute, I'm kind of interested in micronutrients. And there are studies showing that polyphenols and polyunsaturated fats will help with cognitive aging. So polyphenol-rich foods, so lots of fruits and things are rich in polyphenols, and then the polyunsaturated fatty acids are like the omega-3s that you find in fish and such. And here was a study that summarized these different studies showing improvement in cognitive performance with both polyphenols and polyunsaturated fats, and decreased Alzheimer's risk with both of those. So in rodent studies, there's even a lot more evidence for these to improve brain aging. But I pulled out just the human studies. Okay. The other thing is a multivitamin, multimineral supplement. And I'm sure you've probably seen the conflicting reports about, it doesn't do anything or it's helpful. So our bottom line is, yes, we all wish that everybody would get the vitamins and minerals that they need from a healthy diet, right? But we realized even in the Institute that the healthiest of us doesn't always get everything, all the requirements every day with the diets that we're eating and such. And so a multivitamin, multi-mineral is a cheap insurance package. It costs about 10 cents a day, and it makes sure that you're covered in case you don't eat everything that you should that day and such. So we do recommend that that it's a good insurance policy and relatively cheap. Okay, so again, to kind of summarize, we've got sort of multiple functions of the brain that are showing declines, and that it's starting relatively early in life. We do think that the best thing to do is to start early, and that it's going to take a number of dietary and lifestyle factors to have a big impact. But as was mentioned in the latest talk, there's still things that you can do later on that can have an impact. But we're concentrating at the Linus Pauling Institute. We're kind of concentrating early on to see what we can do to make an impact on that food curve. So again, I kind of mentioned this thing. You're probably a little bit frustrated with the fact that you hear conflicting results. 1 week caffeine is good for you, the next week caffeine is bad for you. And so I just wanted to kind of mention, it's like, it basically is the challenge of doing human research. This is from somebody who has mostly done rodent research but are moving into human research. We don't have the control in human studies that we do in animal studies. So we don't have the benefit of having clones that we can work on and have less variability in our data. And we can't get people to live the way that we dictate. The other thing I've learned is that rodents show up for the study, but the people don't always. But at any rate, so we've got a lot of different factors that we're dealing with, and especially with an older population, you've got that sort of lifetime of factors, because education level impacts on brain aging and things like that. So it's a challenge, but I think that we're up for it. I would encourage you to support biomedical research so that we get more data. Part of the issue, I think, with these studies, conflicting studies, is you've got different subpopulations of people. And so the more studies we can do that can get a broader sampling and things like that, the more we're going to be able to make good recommendations and such. So I think support biomedical research. One of the biggest problems we have right now, funding at NIH is very tough right now. And that's going to cause a problem in the short term with knowledge coming out and new things coming out. But the bigger problem I see is in the long term in training the next generation of scientists. It's like right now, these young people don't see science as being a fun career or something to get into. And so I'd like to see that change. The other thing you can do is get involved in research yourself. So again, it's like make sure that the studies are relevant to you and your situation and such. The Center for Healthier Aging Research at OSU has the Life Registry, and we're always looking for volunteers. It's different types of studies. We're a multidisciplinary group, so it's anything from answering surveys to maybe coming and working with me and getting cognitive testing and things like that. So if you're interested, please contact them. All right, and I guess we're going to wait until the end for questions.